Today let's learn about valency, and under valency we are going to learn three definitions of valency. There are three elements which are taken as the standard elements, and with respect to those standard elements we are going to see the valency. So those elements are hydrogen, chlorine and oxygen. Apart from these, we are going to also learn what is variable valency and which elements show variable valency. So let's start the lesson. We'll start the definition of valency with hydrogen. So as we know, there are three definitions, so we'll start with hydrogen definition. Valency or combining capacity of an element is expressed in terms of the number of hydrogen atoms which combines with or displaces one atom of the said element. So we are going to take one element and we are going to see that particular element can combine with how many number of hydrogen atoms, or it can displaces how many number of hydrogen atoms. So let's take an example to understand the definition, which sounds a little confusing, but actually it's very simple. So let's take an example. For example, if I have water, H2O, here oxygen combines with, one atom of oxygen combines with two atoms of hydrogen. So we can say the valency of oxygen is 2. Valency of oxygen is equal to 2 because one atom of oxygen is combining with two atoms of hydrogen. Similarly, let's take another example, NH3. Now here one atom of nitrogen combines with three atoms of hydrogen, right? So that is why the valency of nitrogen is equal to 3. Like this, we can take a lot of other examples. Now let's go to the next definition. There are some elements which do not combine with hydrogen. So how do we calculate the valency of those elements? Those elements can combine with chlorine. So the definition with respect to chlorine is almost the same as the hydrogen definition, just that here in place of hydrogen we are using chlorine. So the valency or combining capacity of an element is expressed in terms of the number of chlorine atoms. So remember here, number of chlorine atoms which combines with or displaces one atom of the said element. So let's take an example to understand. It's very simple. Suppose I have ZnCl2. So I have to find out that one atom of zinc combines with how many atoms of chlorine. So here I have one atom of zinc which is combining with two atoms of chlorine. So valency of zinc is 2. Similarly, if I take AlCl3, then I can see that one atom of aluminium is combining with three atoms of chlorine. So valency of aluminium is 3. So like this, we are going to find out the valencies of different elements which combine with chlorine. Same way, there is another definition with respect to oxygen. This is a little different from other two definitions. So let's see what is the definition. Valency or combining capacity of an element is double the number of oxygen atoms. So remember here, double the number of oxygen atoms which combines with one atom of the said element. So just that we have to double the number of oxygen atoms which combines with one atom of the element. We can take some examples to understand this better. Let's say MgO. So here one atom of Mg combines with one atom of oxygen. So what we are going to do to find the valency? We will just multiply by 2. So the valency becomes 2. Al2O3. Let's take another example. Al2O3. Now let's find out one atom of aluminium combines with how many atoms of oxygen? Now here from this ratio we can see that 2 atoms of aluminium combines with 3 atoms of oxygen. So 1 atom of aluminium will combine with 3 multiplied by 1 divided by 2. So how much is it? It's 1.5, right? So now to find the valency of aluminium, I have to multiply 1.5 multiplied by 2 because it's double the number of oxygen atoms. So here we have found out that 1 atom of aluminium combines with 1.5 atoms of oxygen. So the valency is double the number of oxygen atoms. So 2 multiplied by 1.5, which is equal to 3. So aluminium valency is 3. This is what we got from the chlorine definition also. Aluminium valency was 3. Now here also we got the valency as 3. So all these definitions altogether give the same meaning and same valency of the elements. So there are some elements which have only single valency. There are some elements which have variable valency. So we are going to learn about those variable valencies also. Now suppose any element has valency 1. That is called a monovalent element. Some elements have valency 2 like zinc, that is a divalent. Some are having valency 3 like aluminium, so they are trivalent, and so on. If you have valency 4 like carbon, that is called tetravalent, and so on. But there are some elements, as I mentioned, which show variable valencies. These are mostly the transition elements. For example, let me take FeCl3 and FeCl2. Now, in the first compound, we can see that 1 atom of Fe combines with 3 atoms of chlorine. So, hence the valency of Fe is 3. And in the second, 1 atom of Fe combines with 2 atoms of chlorine. So, the valency of Fe is 2 over here. So, same element iron has valency 3 and 2 with the same element again, which is chlorine. So, this kind of representation is known as variable valency. Now, to differentiate between these two valencies, what we write in the name of the compound is the name of the metal element ends with OUS in case of a lower valency, and it ends with IC in case of a higher valency. So we can say that FeCl3 is ferric, the suffix IC is added, it's ferric chloride, and FeCl2 is ferrous chloride. So the suffix OUS is added. So that when I say ferric chloride, then I know that the formula is FeCl3, and when I say ferrous chloride, then I know the formula is FeCl2. So this is to differentiate between the two valencies. Similarly, I'll show you another example with mercury. So Hg2Cl2 and I have HgCl2. Now in the first one, 1 atom of Hg combines with 1 atom of chlorine, so the valency is 1. Here 1 atom of Hg, which is mercury, combines with 2 atoms of chlorine, so the valency is 2. So the first one can be called as mercurous chloride, OUS should be added to the metal element, and the second one is called as mercuric chloride to differentiate between the two valencies. Similarly, tin also shows the variable valency SnCl2 and SnCl4. Clearly we can see SnCl2, tin has a valency of 2, and in SnCl4, tin has a valency of 4. So the first one is stannous chloride and the second one is stannic chloride. So OUS and IC are again added to differentiate between the valencies. So these are some details about the valencies and the definitions and how do we calculate, and also the variable valencies. I have given you a list in which the valencies of various elements are mentioned. You all can go through this list. Then here we have scandium to zinc, gallium to strontium, and so on. These are some elements which are having variable valency. I have already discussed iron, tin, mercury with you. Apart from them, you can have copper. So copper 1 or cuprous, and copper 2 is cupric. Then you have silver also, which shows argentinous and argentinic. And then you have mercury, mercurous, mercuric, which we have already discussed. Iron, ferrous, ferric. Tin, stannous, stannic. Lead is plumbous and plumbic. So these are the elements which show variable valency. I hope the concept of valency is clear for you all. Thank you for watching the video.